Okay, let's start learning Lee group, reading Knapp's book. Okay, Lee group. And 12 February 28. March 1st. Okay, let's start first section. Closed linear group. Closed linear group is a group of real or complex matrix that is logical across in complex generally group unitary group. A special linear group provided from the linear algebra Z is a central derivative at Z matrice. Ct equals 0. T or equal to identity 0 derivative dt dct is Z. And the set matrix is indeed a linear algebra. The exponential root of square matrix is defined from a parallel series of exponential functions. The exponential map enables one to compute the linear algebra, and each of from a there is an exponential map carried z into z. Z exponential mapped into z. From this fact, one deduces the main result of intersection that any closed linear group as a smooth manifold that makes the group into linear group. Let's get right. From this fact, one is the main result into any closed linear as a natural lecture smooth manifold that makes the group into a linear group. A homeomorphism pi to closed linear z pi homeomorphism smooth curve through the identity smooth curve through identity. The map on the derivative outside curve is broad linear algebra homeomorphism d pi related by identity pi xp equal xp d pi. This idea is a quantitative version of the statement infinite behavior homeomorphism identity determines the homeomorphism in neighborhood of the identity. Okay, first, linear algebra across linear group. Many readers of this book we already know some amount of the elementary theory. Yet it may be helpful to review some of the theory in special case, namely for group matrices that are vertical. The reason is that it is a technique that comes into play for these groups are more likely in more power. Thus, the review in this introductory chapter is intended to assure the spread in which may result example will be approached later in the book. Let's take the LNR as a first example of Lie group, closed linear group. Is a real original linear constant or non-singular element with matrix have turbulence if we define the in fact and is open substance in because substance with polynomial function multiple inversion conjugate because they are in enter very division Python topological group. We shall refer to any closed subgroup sum as a closed linear group. We shall refer any closed subgroup sum as a closed linear group. The linear there's a closed linear group. Any closed linear group inherits rows from a few more examples of closed linear SNR, SLNC. The first three are the numeric and special. The last two are the special. The reason that is subsequent closing is that they are different polynomials. The polynomial is expression entry by entry relation in real. amount to the different equation for further example of closed line will be. Okay, the size of closed linear group being from the fractal kind of different is better than in closed group. We can speak of smooth curve in the numeric city into the underlying material space whose image. We are especially interested in smooth curve in the with the properties that an example is the curve ct cos t sin t t cos t in the group special or 3. Yeah, for any such curve we can form the zero which be some with c. For example, you can be 間違うでcos t sin t. Yeah. So c dash 0 t equals 0. We conclude 0 is 1 minus 1 0 0 0 0 0 0. Here c dash 0 tell us the direction in which the curve. Here c 0 tells us the direction in which the curve extends from 1. We may think of it as saying how parameter c is to start from. Z equal c dash 0 c z curve with c0 1 smooth. More you can. Then z is the subset matrix the same size as the original matrix, the same size as the originally. The number are not necessarily invertible. The set z has a certain amount of structure. Plus z is a real vector space. So z vector being the forming ct, yeah, dt ct bt equal so t equal 0, b dash 0 plus c dash 0. So z is closed under addition, and so we can add any arbitrary two elements in z. Yeah, addition is closed. To see closure under square multiplication, you can check very easy. So let since 0 being z, and let k forming ckt. Yeah. I couldn't catch up now, so I lied. So ckt is kt k. So t equals 0, k c dash 0. So scalar multiplication is also closed in this algebra z. So z is closed under scalar multiplication. Second, z is closed under conjugation. Zx z inverse z. Fc is smooth curve in the passing through 1 axis, then so the ct reflection to t0 we see that is in z. That z is closed under the linear map at z. Then any given by at zx z close z is closer, and the group conjugation g is close. Of course, I think so. Z is close. G is close. Linear map at z. Z, yeah, so, yeah, Z, add Z to Z. So, Z is, I think, endomorphism of Z. Instead, let X be in Z and let CT be. Then, the CT is a smooth function into Z, as we see by switching Z. Right matter. By definition, we have dt adct x what the fuck? The x in z, I don't know. Let's see the smooth. Sad, then t add sad add c. The x is a smooth function into z. It's a smooth function into the as we substitute. Add ctx. Add ctx. So as ct and we know the left side is the right side in the passage to the or wrong with the since z as a relative service of the is cross running the is correct to this limit. As it x, so x, what are you talking about? As it x, what is x? X, I think. What is x? X in z. Yeah, x in z. Yeah. The right side involves vector space projection passage since z as a vector space. We need a prime from your namely. So dct the inverse minus ct inverse is still c. To see this we differentiate differentiate and by being careful about the order in which right. Being careful about the order in which we write down products we obtain ct inverse per ct. You can easily get this differentiate. Yeah, you can write. So dt edit ct x x did x. So it's a very easy question and yeah. Of course. Literally. This is right. Yeah, this is right. Yeah. So the with that. Yeah. So we call that z is cross under lay bracket. So we call I think this is very new for me. in terms of introducing labor that kept. I'm surprised. What is this? The Lie bracket operation is linear in its vertical. So this a Lie bracket operation is a xx equals 0 for xz. Hence xy minus yx really. It's really. Hence xy I don't know, B Yakov identity permute each term orderly, so there are 3 terms is correct or for x right to x y. A real vector space with a operation xy is a linear divergent satisfied. Layer of the organic record Z is linear of the cross subspace. General NR is the space of ordering and general NC linear object material Z is a linear object Z L NR Z L and C respectively. For some bracket for Z SO3, we have already used a curve inverted consistent sign tool. Is one member of linear algebra Z. Yeah, you know, I think I already calculate in example in the previous example. So I think I think Z of SO3. Using direct curve inverted consistent sign, we can see the matrix. And light in Z, taking into account the vector space coordinate, we see that Z skew symmetric real 3 by 3 times. Skew symmetric. Actually, equality holds in this inclusion. In fact, so thank you, to break this. We see that. I know, yeah. Special 3 dimension skew symmetric. Cosine using curves involving cosine, we see actually equality holds in this inclusion. In fact, then sorry, it is so to 10. I don't know. Really? No. This is that's the linear algebra of SO3 is XZL 3R X plus XTZL. For the 5 example, we define when X 0 and C X plus X bar 0. And C true. So yeah. Shortly, we shall see that this is the range of the cross horizon is the argument is the same as for problem. The kind of argument is shows a linear of the satisfied z when I don't know z un shows that the prime problem the kind of argument has a linear language. For SRN, the argument is the same as for SR. For UN, the kind of so the linear object UN satisfies GUN? What? The UN satisfy the linear. What? I think this should be equal because the definition of the I don't know. That is, we can see also by the techniques of the linear object the expected satisfy the as numerous ray. Really? The SU M Z SL SL why? Okay. This is the once we bring to bear a differential polynomial involving it, if CT is a smooth curve, DT, yeah, this is a very dress tell. Law of CT has been different. There's everything T0, one of the determinant result in the determinant of the matrix, and hence everything is directly. So, my equality holds in its but proof. What the equality holds in its case, but the proof of equality will have to avoid deviation. Is a property exponent mapping from matter. Although we can identify the holes in chapter 2. We identify the linear of the complete ring, or we have the exponent mapping with her. We can't say much else about much extra. We can decide whether this is there later to we enable us to see that they can't be there unless they are discrete group. Exponential matrix. It's possible also to go back plot from Z. The tool for doing so is the exponential matrix. Exponential is, for any n by n complex matrix, say EA is given by matrices moreover EXY X is moreover X is non-singular. The smooth curve. ETX is continue. ETX more determined EX equal E trace. is a sensitive mapping from map. プルーフはいらないかな。まあ、proof. I think you can easily prove it, but to equal space, the right and hence the x, y, yes, so, and you should, right, so, x prime, y, n, so, x prime, so, yeah, something like that, yeah. Yeah, and I think each question is very easy if we accept it. So it's inventory of the diagonal entries, or it's inventory diagonal. A general block method is all from this upper triangle. Then we have there the x upper angular determines the x is the x inverse and determine x. Yeah. Conclusion F follows from standard practice above. Conclusion F follows from standard practice temporary differential. So let's understand the problem with the linear object for is identify the equation for each of the point in each case in the with the left side of the line, then combination ATX line corresponding group. According to CD. The point in each case F is the right side of the line. Then our combination shows that ATX lines. Since according to CD in the project ATX smooth curve matrix, we come to X is the security mass hold. And so, for example, consider Z UN. If x satisfies x plus x, the asterisk. So hence it is UN x must be in the linear object in view of the linear object of UN equal UN. For another example, according to Z and SM and R, if x satisfies trace x equal UN, hence ETX is in UR, x must be linear object. What about the okay? I have consumed my all concentration power, so I quit now. See you next again.